Hi everybody, it's me, Damon, power delivery guy at Intel Desktop Boards again. Today I wanted to talk about dynamic phase shedding. And the reason why we do dynamic phase shedding is to keep the efficiency high. And so I thought I'd go through that a little bit with you. So if here's like a depiction of a really simple regulator for CPUs. The input voltage is 12 volts. 12 volts comes in, and the CPU only needs 1.5 volts. And the CPU kind of looks like a resistor. And if we were just hooked up a simple regulator, we could pick to have another resistor up here. And we might change the value so that when CPU drew more current, then this would go up or down depending, and keep the voltage constant at 1.5 volts. And that would work just fine. The problem is that 1.5 volts is only about 12% of 12 volts. And so the efficiency would look like this. 12% of the current lands in the CPU and 88% of it's used up by the regulator. And so we'd have a nice flat efficiency, but it'd be really low. So to get around that, we use switchers. And how these work is you never, in this high resistive time, you either all the way on or all the way off. And just like the name says, it just switches boom, 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 on, off, on, off, on, off. And it turns out that it has a 12% duty cycle. And we filter that square wave back out into DC, and we get a really high efficiency at a really high current. And as current goes up a little bit, efficiency goes down, because there really is a little bit of resistance in these guys. They burn a little bit of power. And as current goes down, efficiency goes up a little bit. But then it goes like this. And the reason it does that is because even when there's no current at all, you're still switching, and it costs energy to switch. See, like I have got a board set up right now. It's 1.5 volts out. I'm drawing no current on it, and yet one phase is still switching away. So our efficiency is 0. We're putting 0 amps out into the load, but we're still using energy in the switching on and off, switching on and off. So the strategy is, if you're running a regulator with a lot of phases in it, really large power, then as load goes down, you want to turn off some phases and keep power low. And then it behaves like a regulator with less phases in it, and it looks like this. Efficiency, the optimal point moves down, and at higher currents, it gets even lower efficiency. But you can keep turning off phases and turning off phases and turning off phases, and you can get all this efficiency back. And so that's what dynamic phase shedding is about. It's about getting a lot of efficiency over as many power bands, high and low, as you can. Okay, so here I've rigged up an example, and we can see that the board's running away. It's just got one phase going right now. The output voltage is 1.5. And then I can turn on some load. That's about 5 amps. And look, 2 phases have turned on. Now I can turn on some more current. That's another 10 amps plus 5, 15. And look, 4 phases are on. Last one, another 20 amps. All 8 phases on. High efficiency across all power bands, just like we wanted. And the reason they call it phase shedding is as load goes down, the number of phases goes down, and that gets us the high efficiency all the time.